Yes, good afternoon, students. Let us continue that objective questions on electrostatics. Okay. Yes. See, students, we are solving question number 20 on previous class, on that previous class. Okay. Now, see, students, question number 20. What they have given is a conducting sphere of radius 10 centimeter has an unknown charge. If the electric field at the distance 20 centimeter from the center of the sphere is 1.2 into 10 to the power of 3 Newton per Coulomb and points radially inwards, the net charge on the sphere is. So according to the question, there is one sphere which is having a unknown charge which we need to find. And this sphere is having a radius which is equal to 10 centimeter. Now, if the electric field at a distance of 20 centimeter from the center of the sphere is, so from the center of the sphere at a distance of 20 centimeter, they have given the electric field. So the distance of 20 centimeter, electric field is given as 1.2 into 10 to the power of 3. Yes, 10 to the power of 3 Newton per Coulomb. Clear? Yes. Then, and the two, they are saying that electric field is point radially inward. Then what should be the charge? See, students, if the electric field is toward the center of the sphere, then the charge should be negative. This point, make it clear first. Means your option should be negative. Means either it is A or B. Clear? Now let us find the value. See, as we know, for a sphere at an outside point, electric field is given as E is equal to 1 by 4 pi epsilon naught Q by R square. Dear students, yes, E value is 1.2 into 10 to the power of 3 is equal to 1 divided by 4 pi epsilon naught value is 9 into 10 to the power of 9 into Q value we need to find divided by R square. See here R value given in centimeters. You need to convert it into meters. That is 20 divided by 100 because 1 centimeter is 1 by 100 meters. No? Yes, it is 2 by 10. Clear? Or 0.2 meters whole square. Clear, students? Yes. Now you want the value of Q. Send these to that side. You will get 1.2 into 10 to the power of 3 into 0.2 whole square divided by 9 into 10 to the power of 9. Nana. See, students, you will get 1.2 into 10 to the power of 3 into 0.2 whole square is 0.04 divided by 9 into 10 to the power of 9 is equal to Q. Yes, this 10 to the power of 3 can be removed by removing these points. Okay, 1 0 is given to remove 0.2 and 2 zeros are given to remove this. Clear? Means it can be written as 12 by 10 into 10 to the power of 3 into 4 by 100. Clear what I am writing? Understanding now? Divided by 9 into 10 to the power of 9 is equal to Q. Is 2 zeros, 1 0, 3 zeros, 3 zeros cancel. What you will get is Q value as 12 into 4 divided by 9 into 10 to the power of 9. See here, 3 3s are 9, 3 4s are 12. It is 16 divided by 3 into 10 to the power of minus 9. So 16 by 3 is nothing but 5.3. Okay, into 10 to the power of minus 9. So value of charge should be 5.3 into 10 to the power of minus 9 coulomb and it should be negative. Negative Y understood, I think so. So option C is right answer, Nana. I hope you understand it clearly. Next, let us go to question number 21. See here in this question, they have given that an oil drop of 10 excess electrons is held stationary. Yes, this point is important under a constant electric field of 3.65 into 10 to the power of 4 Newton per Coulomb in millicoins oil drop experiment. The density of the oil is given 1.26 into 1.26 gram per centimeter cube. Radius of the drop is what? We need to find. Here they have given to take the value of G as 9.8 meter per second square and E charge of electron as 1.6 into 10 to the power of minus 19 coulomb. Here the question is, there is one oil drop which is having 10 excess of electrons, means charge on that oil drop is 10 electrons, and imagine this is having some weight, so due to that it will go down. Now it is held stationary by using one electric field in this direction. If you use electric field, yes, a force will act on that charge q in upward direction. So according to the question, they are saying that it is held stationary. It is held stationary means mg should be balanced with qe. Clear, students? Then what will be the radius of the oil drop? They're asking. Yeah. How to find radius? See, here it is a solid. Water drop means nothing but solid sphere. It is in the form of solid sphere. Yes. So we need to write the mass of the solid sphere in terms of volume and density. Yes, we know density is equal to mass by volume. That implies volume can be written as, yes, that implies mass can be written as, sorry, here density can be, yes, we know density formula is mass divided by volume, no, yes, sorry, uh, then mass can be written as density into volume. So we can replace here rho vg is equal to qe. Clear, students? Then v can be written as qe by rho g. Clear? And as we know, solid sphere volume can be written as 4 by 3 pi r cube is equal to QE by rho G. Yes. Then R cube can be written as 3 divided by 4 pi into QE by rho G. Clear, students? Yes. Then what is R value? R value is nothing but power 3 send that side. It will become cube root of 3QE divided by 4 pi rho G. Now substitute the given values. So R is equal to cube root of 3 into charge how much na? 10 into electron. Electron value is given, charge of electron 1.6 into 10 to the power of minus 19 into electric field. Electric field is given 3.65 into 10 to the power of 4 divided by 4 into pi value 3.14 into, okay, rho value is given, rho value 1.26, rho density is given 1.26 gram per centimeter cube. We need to write in kg per meter cube because kg per meter cube is SI unit. Okay, yes, 1.26 into 10 to the power of minus 3 kg per meter cube is rho. Yes, let us use that 1.26 into 10 to the power of minus 3, okay, into g value is given as 9.8. Okay, now multiply all these things, multiply all this and divide and find the cube root of that. You will get the required answer. So answer is 1 into 10 to the power of minus 6 meters. You will get, Nana. Do these calculations, you will get the required answer. The procedure how to solve the problem I have given. Okay, yes, option A is the right answer, Nana, for this. Okay, I hope you understand it clearly. Now let us go to next question. Question number 22. They have given that a positive charge capital Q is uniformly distributed along a circular ring, a CL diagram of radius capital R. A small test charge small q is placed at the center of a ring as shown in figure. Yes. According to this figure, what will happen? We need to see. Clear, students? Yes. Let us see that. Yes. Wait, Nana. Huh. Now, according to question, what they have given is, yes. See, students, I'll try to show you here. Okay. Now options I'll see. So question understood, no? What they have given is positive charge capital Q is uniformly distributed along the circular ring of radius capital R. A small test charge small q is placed at the center of a ring. Then what will happen? Okay, yes, options also they have given. Okay, students? Yes. Now, so here a ring is there and on this ring a positive charge is uniformly distributed according to the question. Okay, and this ring is having a radius capital R, they said. Now at the center of a ring a small positive charge is placed. There's one charge is placed, they said. What they said? They said a charge is placed at the center of a ring. Then what will happen? See option A. If Q is positive, means Q is greater than 0. Greater than 0 means positive. And is displaced away from the center in the plane of a ring, it will be pushed back towards the center. Is it? Is it happens? You check. See, this is positive charges and this is also, if suppose if it is, this is also positive. Now exactly at the center, as you know, electric field will be 0. As you push this towards this, what will happen? Due to this such charges, repulsion will increase. Due to discharge charges, repulsion will decrease. That means a pushing force will act on it in backward direction, so it can come back. Possibility is there. So option A is right answer. I hope you understand what they said. If Q is positive and is placed away from the, and it is displaced away from the center in the plane of the ring, it will be pushed back towards the center. Yes, along the axis of a ring electric field will be there, it will be pushed backside because it is a positive charge and electric field is also positive charge. Okay. Next, option B, they said if Q is negative, means less than 0 means negative, and it is displaced from the center in the plane of a ring, then it will never return to the center and it will continue move till it hits the ring. Yes, if it is negative charge, then what happened? If it is displaced from its center, attractive force will act more this side. So it will be attracted towards that side so that it can hit that ring. Clear? Yes, it is also possible. So option B is also right answer. Next, option C you see. If Q is negative, again Q is negative, and if it will perform SHM, simple harmonic motion, for small displacement along the axis. See, ring is there along the axis now. Now till now for option A, option B, this side like this you have displaced. Now along the axis if you displaced, then what happened? It will move that side, and due to due to law of inertia, it will overshoot the center and it will go that side. Again it will be backside. So like this it will perform SHM. Option C is also right answer. Now the perfect answer for this is option D. So all of the above is right answer. Okay, it is a conceptual based question, Anna. I hope you understand it clearly. Okay, next let us go to question number 23. Okay. They have given that under the action of a given coulombic force, the acceleration of electron E is given. Acceleration of electron is given. Okay, 2.5 into 10 to the power of 22 meter per second square. Okay. Then the magnitude of acceleration of proton under the action of same force. See, point they are given under the action of same force. They said, what is the acceleration of proton? Question mark. Clear? Yeah. Force is same force. I hope you understand the question. There is some forces acting on electron. Due to that force, electron is getting accelerated by this much. Now, same force is acting on proton also. Then what will be the acceleration of proton? As you know, acceleration is nothing but force upon mass. Clear, students? When force is same in both the cases, you can write acceleration is inversely proportional to mass. Means acceleration of proton by acceleration of electron is equal to mass of electron by mass of proton. I hope you understand because it is inversely proportional. Because you want acceleration of proton, it can be written as mass of electron by mass of proton into acceleration of electron. As you know, mass of electron is 9.1 into 10 to the power of minus 31 kg divided by mass of proton is 1.67 into 10 to the power of minus 27 kg into acceleration of electron value is given 2.5 into 10 to the power of 22 meter per second square. Clear, students? Yes. Clear? So if you calculate, you will get it as 13.6 into 10 to the power of 18 meter per second square around. Okay, yeah. See options 13.6 here, 16 is there, 14 is there. Means it can be written as, yes, 14 into 10 to the power of 18 meter per second square, and it can be written as 1.4 into 10 to the power of 19 meter per second square. No, yes, we can write. Means option C is right answer. Now you need to see the option, then you need to change your answer. Clear? Yes, this is the concept. Force is same, they said, that's why. Okay, yeah, I hope you understand it clearly. Next, let us go to next question, Nana. Question number, yeah, sorry, wait. Question number 25. Huh. See students, in question number 25, they have given that the ratio of magnitude of electrostatic force and gravitational force between the electron and proton. Here there is one electron is there and one more proton is there. Okay. Now between these two, electrostatic force of attraction will be there and gravitational force also will be there. Okay. They are asking what is the ratio of electrostatic force and gravitational force? Question mark. As you know, electrostatic force between any two charges is 1 by 4 pi epsilon naught. Yes, I'll write 1 by 4 pi epsilon naught q1 q2 by r square. Okay. And here q1 is charge of electron, q2 is charge of proton, and r is the distance between them. See here, you maintain, let us imagine these two are separated by some distance r. Now gravitational force can be written as g m1 m2 by r square. Mass of proton, mass of electron, you can say. Mass of proton and mass of electron. Now let's take the ratio between them. What you will get? So Fe by Fg will be equal to 1 divided by 4 pi epsilon naught. Value is, 9 into 10 to the power of 9. Clear students? Yes, 25th question we are solving. Okay. And Q1 charge of electron 1.6 into 10 to the power of minus 19 into Q2 charge of proton 1.6 into 10 to the power of minus 19 coulomb divided by G value 6.67 universal gravitational constant 6.67 into 10 to the power of minus 11. Okay, Newton meter square per kg square is the SI unit. Okay, into mass of electron 9.1 into 10 to the power of minus 31 kg into mass of proton is 1.67 into 10 to the power of minus 27 kg. Clear? Yes. Divided by r square cancel. You will get calculation. If you calculate this, you will get it is around 2.3 into 10 to the power of 39. You need to do calculations. No? Remember this value. Okay. Yes, 2.3 into 10 to the power of 39. Yes, option B is right answer. Clear? Do these calculations, you will get the required answer. Okay. Next, let us go to question number 26. Yes, students, it is somewhat important questions. JE students and NEET students, be careful with this type of questions. Whatever I am marking, they are important. Okay. Now, see students, here they have given a question that the electrostatic potential, yes, this concept is still not started, but next chapter we will discuss about this point. Okay. Electrostatic potential inside a charged spherical ball is given by phi. Electrostatic potential we will indicate with letter V, Nana, and that has given here as phi is equal to, it is not flux, remember, potential they mentioned. So that's why I am writing phi, V. Don't think that phi means flux. It is potential they mentioned. Okay. Potential is given as A r square plus B inside a ball, where r is the distance from the center. A and B are constant values. Then the charge density inside the ball is what? What is the charge density inside the ball? This is the question mark. Here there is a ball, spherical ball. So at any point r distance, potential is given. What is the charge density on that ball? As you know, charge density can be written as charge upon unit volume. Volume. It is. It is not potential. Potential symbol is V. Volume symbol also V. Okay. Yes. Students, I hope you are understanding. Clear? Yes. See, first volume, how much volume of this sphere, how much? Na? Volume is 4 by 3 pi small r cube. Okay, let us imagine this is having a radius small r. Okay, yeah. Now we want the charge. What is the charge inside the point? Okay, so for this charge, you can go with the Gauss law. Clear, students? Yes. So what is Gauss law? As you know, surface integral of electric field over a closed surface is equal to charge enclosed upon epsilon naught. So if you want charge, you need to find electric field. Yes. First find electric field. There is one relation between electric field and potential. That is E is equal to minus dV by dr. Electric field is negative of potential gradient, we call it. Is very important formula. Derivation also is there, we will discuss. Okay, yes. So E can be written as minus d by dr of S. Potential value is given as ar square plus b. Okay, now let us differentiate this. Minus d by dr of ar square. A is constant, as they said. A and b are constant. So A constant, it will come out of the differentiation. Now you are having d by dr of r square is nothing but 2r, plus differentiation of constant is 0. So electric field is minus 2ar. Electric field value we got. Yes. So electric field into surface integral of ds can be written as q by epsilon naught. So electric field value is minus 2ar into surface integration of this spherical surface is 4 pi r square. Clear, students? Is equal to q by epsilon naught. Then q can be written as epsilon naught, then send that side. 4 to the 8 minus a epsilon naught r power 4 s. This is q. Pi also is there. Okay, now this q substitute here, you will get charge density, that is rho, as q by volume. Sq value is minus 8 pi a epsilon naught r power 4 divided by 4 by 3 pi r cube. Pi cancel, 4 ones are 4 twos are, r cube cancel with r. Yes, you will have minus 2 3s are 6, 3 will go to numerator, 6 a epsilon naught r. Yes, this is the surface charge density. Okay, yes, 6a epsilon naught r. Option is there, minus 6a epsilon naught, sorry, epsilon naught r. Yes, option B is right answer. Clear, students? Yes, I hope you understand how we are calculating. So first keep in mind what we need to calculate. For getting that value, we want q. Q you can get with any method. See, here I am using Gauss law. So by using Gauss law, if you want q, you need to find the value of electric field. For finding the electric field, they have given the potential value. So when you know the potential, you can find the electric field by using this relation. Clear? I hope you understand it clearly. Next, let us go to question number 27. See, they have given electrical as well as gravitational effects can be brought to be caused by fields. Yes, you know. Which of the following is true of electrical and gravitational fields? About electric field and gravitational field, which option is right answer? They are asking. Yes. Option A, the field concept is often used to describe the contact force. No, this field concept is used to describe the non-contact force. Clear? They said contact force, so that's why wrong. Next, option B, gravitational or electrical field does not always exist in space around the object. No, they will exist in space around the object. Option B is also a wrong answer. Option C, the fields are useful for understanding the forces acting through a distance. Yes, it is right answer. This gravitational field and electrostatic field, these concepts are useful for understanding the force acting on charged particles and on massive objects. Yes, option C is right answer. Next, option D, there is no way to verify the existence of force field since it is just a concept. No, we can verify the existence of field. Okay, option C is right answer, Nana. I hope you understand it correctly. Okay, yes. Now, question number 28. Let us go to question number 28. See, students, in question number 28, they have given that if an object of mass 1 kg contains 4 into 10 to the power of 20 atoms, if one electron is removed from every atom of the solid, from total solid, one electron is removed from every atom, then charge gained by the solid in 1 gram is how much? Simple. In 1 gram of atom, how many electrons are removed? That you find, you will get the answer. Okay. Yes, students. Total 1 kg contains 4 into 20 10 to the power of 20 atoms. Then 1 gram contains how many atoms? As you know, number of atoms formula is equal to number of atoms formula is equal to or otherwise you can say 1 kg contains 4 into 10 to the power of 20 atoms. Now 1 gram contains how many atoms? Clear? Yes. Cross multiply them, you will get the answer, Anna. So you'll get 4 into 10 to the power of 20 divided by 1 kg. 1 kg can be written as, in terms of gram, you write 10 to the power of 3. So you will get 4 into 10 to the power of 17 atoms are there. In how much? In 1 gram. Clear, students? Yes. A simple conversion it is. Okay. Now, so how many atoms are there? That many electrons are removed. Means total charge can be written as N into E. Number of atoms are 4 into 10 to the power of 17 into charge of electron is 1.6 into 10 to the power of minus 19. Clear? Yes, coulomb is equal to 1.6 into 4 is 6.4 into 10 to the power of minus 2 is 6.4 into 10 to the power of minus 2 coulomb. Yes, option B is right answer. Got it, students? Yes. Next, question number 29. 2-point charges of 1 microcoulomb and minus 1 microcoulomb are separated by a distance of 100 angstroms. Okay. A point P is at a distance of 10 centimeter from the midpoint and on the perpendicular bisector of the line joining the two charges. Then electric field at point P is. See, students, it is about a dipole. Here minus q charge is there and here plus q charge is there, and this is the distance between these two. Okay, now they have given that a point P is at a distance of 10 centimeter from the midpoint on the perpendicular bisector. So this is the midpoint you consider, this is the perpendicular bisector. Now at this point, which is 10 centimeter from the perpendicular, from the center, what will be the electric field? Question mark. Okay, see these two, the length of the dipole is given as 100 angstroms. Clear, students? Yes, 100 into 1 angstrom is nothing but 10 to the power of minus 10 meters. It is nothing but 10 to the power of minus 8 meters, we can say. Total length of the dipole is given. And each charge is given as, charge value is given as 1 microcoulomb plus charge. Minus charge is also 1 microcoulomb. So 10 to the power of minus 6 coulomb. So at this distance, what will be the electric field we want? Clear, students? Yes. So how to find? As we know, electric field, see, compared to this 10 centimeter, 10 to the power of minus 8 meters is very small. Yes. Electric field at a point on a equatorial line of a dipole can be given as P by 4 pi epsilon naught into R cube. Clear, students? Okay. That is nothing but A cube, we can say. Clear? Yes. Now, sorry, this point is x, you consider. So x cube we can say. Okay. Yes. What is P, Nana? P is nothing but Q into length of the dipole. So Q value is 10 to the power of minus 6 into length of the dipole is 10 to the power of minus 8. Clear? Okay. Yes. Let us substitute that values here. 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9 into electric dipole value is 10 to the power of minus 6 into 10 to the power of minus 8 divided by x value. X is 10 centimeter. The distance is 10 centimeter. That is nothing but 10 to the power of minus 1 meter. Clear? Yes. So 10 to the power of minus 1 whole cube. So it is 10 to the power of minus 3, Nana. Minus 3, 1 minus 3 cancel. You will get 10 to the power of minus 3, minus 8 is minus 11. Minus 11 plus 9 is minus 2. Clear? Yes, 10 to the power of, sorry, 10 to the power of minus 2. This is electric field, Newton per Coulomb. Yes. Option 9 into 10 to the power of minus 2 can be written as 0.09. Yes, 0.09 Newton per Coulomb is the right answer. I hope you understand it clearly. So you need to remember the formula. That's it. Clear, students? Yes. Let us go to next question. Question number 30. Yes, here it is. Yes, students, see, here is your question number 30. They have given that two charges 20 microcoulomb are placed 10 millimeter apart. The electric field at a point P on the axial line of a dipole 10 centimeter away from its center O on the side of a positive charge is how much? Okay, yeah. So I'll draw a dipole here, minus Q and plus Q. This is the length of the dipole 2A. Now they're asking 10 centimeter away from the center O on the side of a positive charge. So from positive charge, here at this point P, what will be the electric field due to this dipole? They're asking. Yes. See, students, this distance, x distance is 10 centimeter, they said. And the length of the dipole is given 10 millimeters, 10 millimeters. Okay. 2A is given as 10 millimeters. Clear? Yes. So, in that case, what we need to do is, see, simple point, electric field at a point on the axial line formula is 1 by 4 pi epsilon naught 2p by a square minus x square whole square. Clear? Yes. So, when a is very less than x, you can neglect a value, so we can write 1 by 4 pi epsilon naught 2p by x cube. Yes, it is 3 by 2. Yes, it is 3 by 2. Okay, x cube you will get. So in this formula substitute the given values. Q value is given as 20 microcoulomb. It is nothing but 20 into 10 to the power of minus 6, and length of the dipole is given as 2a, given as 10 millimeter, means nothing but 10 into 10 to the power of minus 3 meters. Okay, now dipole moment can be written as q into 2a, as you know. So q value 20 into 10 to the power of minus 6 into 10 to the power of this value minus 2. It is equal to 2 into 10 to the power of minus 7. I hope you are understanding. 10 to the power of minus 8, 1 0. Cancel. You will get 2 into 10 to the power of minus 7. Substitute here. 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9 into 2 into p value 2 into 10 to the power of minus 7 divided by x. X value how much, Nana? X value is given as 10. Where it is 10 centimeter. 10 centimeter is nothing but 10 to the power of minus 1 meter. So 10 centimeter whole cube means 10 to the power of minus 3. Minus 3 cancel with minus 4. Yes, you'll get 9 into 2 into 2, 4. 4 9s are 36 into 10 to the power of plus 9 minus 4 is plus 5. Yes, Newton per Coulomb. Option you check. 36 into 10 to the power of 5 can be written as 3.6 into 10 to the power of 6 Newton per Coulomb. Yes, option C is right answer, Nana. Clear, students? Yes, a simple. What is that one? Formula substitution question is. Next, question number 31. See, students, in question number 31 they have given that in a field free region there is nothing is there. It is a field free region. Two electrons are released to move on a line towards each other with the velocities of 10 to the power of 6 meter per second. The distance of their closest approach will be nearly. So here two electrons are there, na? Here one electron and here one more electron. See, they are, suppose they are released such that they will move with the same velocities towards each other. Let us suppose it is moving with a velocity v this side, it is also moving with a velocity v this side. They are coming like this. Up to what closest distance they will come? That is, you need to find. See, as they are coming closer, distance between the electrons decreasing. When the distance between the electrons decreases, what will happen? Electrostatic repulsion force will increase. So that at one particular distance, the force between these electrons will balance to not to move these electrons towards each other. Clear, students? Yes. So in such case, what will happen? This kinetic energy of this electron will be converted into electrostatic potential energy. They will stay there. Clear, students? Okay. Yes, we are discussing question number 31. Clear, students? So whatever the kinetic energy these electrons initially they are having, that should be equal to potential energy finally. So initially kinetic energy of electron can be given as half mv square for first electron plus half mv square for next electron should be equal to electrostatic potential energy formula is 1 by 4 pi epsilon naught q1 q2 by r nana. That is, q1 is electron, q2 is also electron. So E square by r we can write. This formula we will discuss. One derivation is there, we will discuss. Okay, remember. So what happened? Up to what closest distance they will come? That is r distance we need to find. Okay, half mv square plus half mv square can be written as mv square should be equal to 1 by 4 by epsilon naught value is 9 into 10 to the power of 9 e square by r. So r can be written as 9 into 10 to the power of 9 e square by mv square. Clear? Yes. So r is equal to 9 into 10 to the power of 9 into e value means charge of electron 1.6 into 10 to the power of minus 19 coulomb whole square divided by m mass of electron 9.1 into 10 to the power of minus 31 kg into v velocities of electrons, that is 10 to the power of 6 meter per second. Yes, 10 to the power of 6 meter per second whole square. Clear? So if you calculate these all things, you will get the closest distance of closest approach value is 2.56 into 10 to the power of minus 10 meters. Okay, yes, 2.56 into 10 to the power of minus 10 meters. Option C is right answer. Okay, I hope you understand the concept here. Initial kinetic energy of electrons will be converted into electrostatic potential energy. This is called as electrostatic potential energy. This formula I will derive in next chapter. Clear? Yes. Let us go to question number 32. See, question number 32. A uniform electric field E is equal to 2 into 10 to the power of 3 Newton per Coulomb is acting along the positive x-axis. The flux of this field through a square of 10 centimeter whose plane is parallel to YZ plane. Yes, this type of question already we have solved. Electric field is given. How much? 2 into 10 to the power of 3 Newton per Coulomb. Now, there is one area whose one side is given. One side is given 10 centimeter. Then area of that square, it is they have given that square. Area of the square can be given as side square. That is nothing but 10 centimeter whole square. It is nothing but 100 centimeter square. But 100 into 1 centimeter is 10 to the power of minus 2 meters. Okay, whole square. So 100 into 10 to the power of minus 4 meters square. That is nothing but 10 to the power of minus 2 meters square area. And now they are saying that this area is parallel to YZ plane. Okay, see students, imagine this is x-axis, this is y-axis, and this is z-axis. So this is z-axis, this is y-axis. So if area vector is along YZ plane, then area is parallel to YZ plane, then area vector will be along x-axis only. That means if you consider area vector, it should be along x-axis. And electric field also, they said it is acting towards the positive x-axis. So I cap I am taking. What will be the electric flux? Can be written as E bar dot A bar, dot product of these two. 2 into 10 to the power of 3 I cap dot 10 to the power of minus 2 I cap. So dot product means simply we need to multiply. That is 2 into 10 to the power of 1 plus 3 minus 2 is 10 to the power of 1. Means nothing but 20. Unit what, Nana? Newton meter square per coulomb. Yes, option A is right answer. What, students? Yes. Next, let us go to question number 33. Question number 33, students. 4-point charges are placed at the corners of a square ABCD of side 10 centimeter as shown in figure. The force acting on a charge of 1 microcoulomb placed at the center of a square. See, students, how to find. I'll give you a simple technique. This is, oh, sorry. This is a square, Nana, they have given. Okay, perfect square, imagine. Now, A, B, C, D are the 4 corners of the square. Okay, at 4 corners, they have kept charges. Here 3 microcoulomb plus, here minus 4 microcoulomb, here 3 microcoulomb, here minus 4 microcoulomb they have placed. Okay, now each side is of 10 centimeter, 10 centimeter, all sides. Now, exactly at the center of this square, center of the square, they are saying, at the center of the square, they have placed a charge that is 1 microcoulomb. Okay, what is the force acting on it? Okay, so if you want force, you can do like this, Q into E. If you find electric field, you can find the force. So first to find the electric field. Okay, students, I hope you are understanding what I am saying. So at this point, first let us find the field. As you know, electric field at any distance formula is KQ by R square, and it will be away from positive charge and towards the negative charge. Clear, students? Yes. See, this total distance, imagine this is R, this is also R, this total distance is root 2 R diagonal, then this will be R by root 2, this is also R by root 2, this is also R by root 2. Are you getting? Yes, distances are equal from the center, as you know it is a square. And see, this is a negative charge, electric field will point towards it due to this, and this is also negative charge, electric field will point towards this due to this. As the charges are equal and the distances are equal, what will happen? Net electric field at the center will be 0 due to these two. Finished? Okay, yes. And again, due to this electric field is this side, and due to this electric field is that side, again charges are equal and distances are equal, electric field is again 0. It is symmetrical distribution of charge. Electric field at the symmetrical center is always 0. If electric field is 0, then force will be 0. Yes, option D is right answer. D is right answer. Clear, students? Yeah, simple technique. Next, let us go to question number 34. See, students, in question number 34, they have given that if there were only one type of charge in the universe, then what will happen? Only one charge is there in the universe, then what happened? What happened? First option, surface integral of electric field over a closed loop should not be 0 for any surface. Is it correct? No. It should be 0 according to Gauss law, because only one charge is present. No. Clear? Next, option B, surface integral of electric field over a closed loop should be 0 if the charge is outside the surface. Yes. If charge is inside, it should not be 0. This is flux. If charge is outside, then flux should be 0. Option C, you see, surface integral of electric field over a closed surface is equal to Q by epsilon naught. If charge of magnitude Q were inside the surface, yes, option C is also right answer. So both B and C are correct. Yes, option D is right answer. Nana. Clear, students? Yes. Okay. Huh. So remaining still 10 questions are there. We'll discuss that 10 questions in next class. Okay. I hope you understand these all questions very clearly. Okay. Thank you. Bye.